Hello, mathematicians. This is lesson 9.1, adding and subtracting polynomials. Now, in this lesson, you're going to have a lot of new words. So here's a couple. A monomial is an expression that is a number, a variable, or a product of a number and one or more variables. So each of the following is a monomial. So if you notice, they're all single. Mono, the word mono means one. It is single, it's by itself. So all of these are by themselves. They're one unit per se. The fraction c over 3 is a monomial, but the expression c over x is not a monomial because there is a variable in the denominator. So you cannot have variables in the denominator. The degree of a monomial is the sum of the exponents of its variables. For a non-zero constant, the degree is 0. 0 has no degree. So if I looked at this one right here, the degree of my monomial would be 3 because I have two x's and I really have one y. They don't put the 1 there, but it's y to the first power. And so then you'd do 2 plus 1 would equal 3. You're just adding the little tiny numbers. Okay? A polynomial is a monomial or the sum or difference of two or more monomials. Okay, so when you write down the word polynomial, that is the big heading, and then underneath it fall monomial, trinomial, binomial. So I kind of explained it before. A polynomial is like the word tree. And then if I were to say, look at that tree, well, it's not just a tree. It could be a maple tree. It could be a pine tree. It could be an oak tree. Could be an apple tree. Like there's many different names for tree, for the types. So a polynomial is the main name. And then underneath it, you have a monomial. You have a binomial, meaning two. Gosh, this is horrible. And a trinomial. So, a polynomial shown above is in standard form, where if you look at this one above, if you look, this is in standard form because each separate thing decreases from left to right. So I start with 4x to the fourth, and then I have x to the second, and then I have my x, and then my numbers go last. So the degrees of each monomial go from left to right. You're going to want to put the biggest one first, and then each one after that. I can't add 3x to the fourth and 5x to the second and get 8x to the sixth because it's addition. I cannot do that. Those are completely separate terms. So notice the degree. This is what we just talked about. This one has a degree of 4 because of the exponent. This has a degree of 2 because of the exponent. This has a 1. And any number by itself has a degree of 0. So here's a little chart if you're still kind of confused. We have monomials, binomials, and trinomials. And if you look here, this is a monomial, this is a monomial. Okay? Now, this is a binomial because it has two pieces. And this is a binomial because it has two pieces. Two terms or whatever you want to call them. And this is a trinomial because I have an x squared, I have an x, and I have a number. Okay, so write each polynomial in standard form. Then name each polynomial based on its degree and the number of its term. So let's do A together. So I'm going to write this in standard form. So that means my negative 9x to the fourth has to come out front because that's the highest exponent. And then I'm going to add 6x squared. And then I'm going to add 7. Now it says name each polynomial based on its degree and the number of its terms. So if I look on this, I have 3 terms. So that is a trinomial with a degree of, now x to the 4th has 4, x to the 2nd has 2, and then 7 has 0. So it would be a degree of 6. So it's a 6-degree trinomial. So try B and C. So in B, I have negative y to the 3rd plus 3y minus 4. So that is a trinomial. And its degree is 3 here and 1 here. So that would be a degree of 4. This one, first I'm going to do 7b minus 11b because those are like terms, so I can combine them. So that would be negative 4v plus 8. So this is a binomial, and it has a degree of 1 because of the v to the 1st power. All right, now it's going to ask you to simplify each sum. So now these are all addition. So if I did this first one, I can only add like terms. So I'm going to add the 12 and the 8, and that gets me 20m squared. And then I'm going to add my 4 and my 5, and that's 9. So if I look at B, I have 3t squared and 1t squared, so that'd be 4t squared. And then negative 6 plus 11 is 5. So I have 4t squared plus 5. So try C and D. Okay, so I have 9w to the 3rd plus 7w to the 3rd is 16w to the 3rd. And then the 8w squared and the 4 I can't combine because they're not like terms. This one I have 2p to the 3rd plus 9p to the 3rd is 11p to the 3rd. And then I have 6p squared and 11p squared, so that's 17p squared. And then I have 10p plus 3p is 13p. So those are really easy. Addition is always so nice and easy. Now here's subtraction. Now the thing you have to remember with subtraction is if I am going to minus a whole set that's in parentheses, I have to minus everything. So if I did A, I'm going to move it right down here, I would do v to the 3rd minus 9v to the 3rd. So that's negative 8v to the 3rd. And then if I have 6v squared, I would minus a negative, so that would be plus. So 6 plus 7 is 13v squared. And then I have negative v minus 3v, because I have to distribute that negative sign to all 3 things. So negative v plus or minus 3v is negative 4v. So try B and C. So for B, I have 30d cubed minus 2d cubed, so that's 28d cubed. Negative 29d squared minus d squared is negative 30d squared minus 3d. And then C, I have 4x squared minus 6x squared is negative 2x squared. Sometimes if you need to draw these, just to remind you, because I forget. 5x minus x is 4x. And then 1 minus 8 is negative 7. All right, that's it for your note.